Hello, my dear student. Welcome to our program of Science Third Private Stage. Today we are going to talk about the third lesson in Unit 1, chemical reaction or speed of chemical reaction. What's meant by speed of chemical reaction or rate of chemical reaction? What is the factor or what are the factors affected of speed chemical reaction? And what is the importance of enzyme? Let's go to our lesson. Speed of chemical reaction. As we know, some reactions occur in short time, such as fireworks. Some reaction between oil and caustic soda take long time. Some reaction iron rusting also take long time to occur, for months or weeks. And some reaction which form petroleum oil in the earth take millions of years. The following reaction in our lesson today is nitrogen pentoxide as a solid matter decomposed into nitrogen dioxide and oxygen as gases. In the previous reaction, we can see that nitrogen pentoxide decomposed to give nitrogen dioxide and oxygen. In this figure, we can see that relation between molar concentration and time. Molar concentration in y-axis and the time. This relation means that the reactant A as plus B as a reactant produce C as a product. Again, in this reaction, we can see that A plus B produce C. In this reaction or in this figure, we can see that the rate of reactant A and reactant B decrease with time, and the product C increase with time. This means that the rate of reaction or speed of reaction over time, the concentration of reactant decrease and the concentration of product is increased. Again, in this figure, we can see the reaction between two compound A and B to produce compound is C. In this figure, we can see that the relation between molar concentration of product and reactant with time. Over time, the concentration of reactant decrease, but the concentration of the product is increased. The speed of chemical reaction is the change in the concentration of reactant and product in a unit of time. We can define the speed of chemical reaction as we see is the change in the concentration of reactant and product in a unit of time. How can we measure the speed of chemical reaction? Measuring the speed of chemical reaction. The speed of chemical reaction is measured by the rate of disappearance of the reactant or the rate of appearance of product. Again, we can measure the speed of chemical reaction as a rate of disappearance of the reactant or the rate of appearance of the product. As example, we can see sodium hydroxide can react with copper sulfate. If a sodium hydroxide as a solution can react with copper sulfate as a blue solution, it produces sodium sulfate and copper hydroxide as a precipitate. Again, sodium hydroxide react with copper sulfate to produce sodium sulfate and copper hydroxide as a precipitate. How can we measure the speed of chemical reaction. From this reaction, we can see that the speed of this reaction is measured by, again, in the previous relation or the previous equation, the speed of this reaction is measured by the disappearance rate of blue color of a copper sulfate as a reactant, or the appearance rate of blue precipitate of copper hydroxide as a product. Again, we can measure the speed of this chemical reaction by the disappearance rate of blue color of a copper sulfate as a reactant, or the appearance rate of blue precipitate of copper hydroxide as a product. Now, we will study factors affect the speed of chemical reaction. Factors affect the speed of chemical reaction, such as the nature of reactant, or the kind of bond in the molecule, surface area of reactant exposed to reaction. Again, the first factor affected chemical reaction speed is the nature of reactant. It divided into two factors, the kind of bond in the molecule, and the second factor is surface area of reactant exposed to reaction. We studied the kind of bond. There are two kinds of bond, ionic bond and covalent bond. As the kind of bond can affect the chemical reaction speed. Let's see. The concentration of reactant. This is the second factor affected chemical speed reaction or chemical reaction speed. The concentration of reactant. The third factor is the temperature of reactant, and the last one is catalyst. The first factor is the nature of reactant, the kind of bonding in reactant. As we studied in the second year and the first year, you can know that the type of bond is covalent bond and ionic bond. But what is the difference in ionic and covalent bond, or how can the kind of bond between molecule can affect it in the chemical reaction speed? The reaction between ions is faster than reaction between molecule covalent. Compound react slowly. Again, the reaction between ion as sodium chloride with sulfur nitrate is faster than reaction between molecule covalent compound which react slowly as caustic soda and sodium to make soup. Again, the reaction between ion as example sodium chloride and sulfur nitrate will produce white precipitate of sulfur chloride faster than reaction between molecule covalent as a caustic soda with oil to form a soap. But why the ion is faster than covalent bond? Because they don't break into ion but molecule. Ionic compound react fast because they break into ion. Again, the chemical reaction speed in ionic compound is faster than covalent compound because they don't break into ion but molecule. Covalent bond react as a molecule, but ionic compound react fast because they break into ion. As example, sodium chloride with silver nitrate. As we see, it decomposes in a solution into ion. It will be faster than covalent compound reaction. White precipitate of silver chloride will be formed as a fast because they are decomposed in a solution into ion. The surface area of reactant, it is the second type of nature of the compound. When adding an amount of iron filling to hydrochloric acid, again, when adding an amount of iron filling to hydrochloric acid and adding a cube of iron with the same weight as iron filling for the same acid. So we will add the filling of iron filling to hydrochloric acid in the test tube, and the second tube we will add a cube of iron with the same weight as iron filling for the same acid. What will happen? The surface area in the case of iron filling is larger than the cube, so the reaction speed will increase, or the reaction speed increases. Again, the surface area which composed to the acid in the iron filling case is larger than the iron cube, so the reaction speed increases. Fe plus 2HCl as a hydrochloric acid, as we see FeCl2 plus H2. In the first picture or the first image, we can see the cube of iron, but in the second image we can see the iron filling which compose to the acid, so the iron filling will be react faster than the cube of iron. The effect of concentration of reactant on the speed of reaction. This is the second factor affected the speed of reaction. Concentration of reactant. Again, the effect of the concentration of reactant on the speed reaction. Let's see. The speed of chemical reaction increase when the concentration of reactant increase. Again, the speed of chemical reaction increases when the concentration of reactant increase. Give reason or why. Because as concentration of reactant increase, more collision between molecules take place, and therefore the rate or the speed of reaction increases. So, if the concentration of reactant increase, the speed of chemical reaction increase also, because as concentration of the reactant increase, more collision between molecules take place, and therefore the rate or the speed of reaction increase. As example, consider the burning of aluminum coil in the following cases. Again, consider the burning of aluminum coil in the following cases. In the first test tube or the first jar, aluminum burn with oxygen found in the air. Oxygen is 21% of air. Again, in the first tube, we add aluminum and burn with oxygen found in the air, which concentration of oxygen in air is 21% of air. MB, aluminum burn in a container which contain pure oxygen. So the second tube, we add aluminum coil with oxygen as a pure oxygen. In B, aluminum burn in a container which contain pure oxygen. Which percentage as 100? What will be observed? The observation in this experiment, aluminum react faster in case B. But why? Because the concentration of oxygen in test tube B is higher than or larger than the concentration of first tube. So, if the concentration of a reactant increase, more collision between reactant increase, so the speed of chemical reaction will increase. The third factor in this lesson affect the chemical reaction speed is the effect of temperature on the speed of reaction. The effect of temperature on the speed of reaction. Increasing the temperature increase the rate of chemical reaction. Why? Or give reason as a question in our exam. Increasing the temperature increase the rate of chemical reaction because the number of collision also between molecules increase. Again, if we heat a test tube or if we raise the temperature of reactant, more collision between molecules increase. So the chemical reaction or the chemical reaction speed can increase also. As example, food must be put in freezer to decrease speed of chemical reaction by bacteria. As example, in the temperature effect of the chemical reaction speed, food must be put in a freezer to decrease speed of chemical reaction by bacteria. The last one or the last factor affect the chemical reaction or speed or chemical reaction rate is a catalyst. What's mean by catalyst? Is a substance which speed up chemical reaction without a change. Again, define a catalyst is a substance which speed up chemical reaction without a change. There are two types of catalyst. Positive catalyst. It is the catalyst which speed up the chemical reaction or most catalyst. Again, positive catalyst, it is the catalyst which speed up the chemical reaction. Most catalyst is positive catalyst. Negative catalyst, it is the catalyst which slow down the chemical reaction. Again, negative catalyst, it is the catalyst which slow down the chemical reaction. What is the properties of catalyst? Firstly, we will study the properties of catalyst. As a factor can increase the speed or decrease the speed of chemical reaction. The first property of catalyst, they change the speed of the reaction without changing the reactant and product. Again, they change the speed of reaction without changing the reactant and product. It is the first property of catalyst. The second one, the mass of the catalyst isn't changed by the reaction. Again, the mass of the catalyst isn't changed by the reaction. The catalyst isn't changed chemically. Again, the catalyst isn't changed chemically. The catalyst combine with the reactant and separate from the product at the end of reaction. Again, the catalyst combine with the reactant and separate from the product at the end of the reaction. The last property is the catalyst is used in a small amount. Again, the catalyst is used in a small amount. Another property, the catalyst decrease the energy needed for the reaction. The catalyst decrease the energy needed for the reaction. From the last properties of catalyst, we can say that the catalyst increase the chemical reaction speed or chemical reaction rate. As example, hydrogen peroxide inside the test tube with a little of manganese dioxide. The hydrogen peroxide will decompose into two products as a water and oxygen. Again, hydrogen peroxide decompose in water and oxygen evolve in the test tube. But if we add manganese dioxide, this reaction will be faster than the without manganese dioxide. Again, manganese dioxide acts as a catalyst, so it will be increase the decomposition of hydrogen peroxide into water and oxygen. Again, manganese dioxide acts as a catalyst in this reaction, so it will increase the decomposition of hydrogen peroxide to water and oxygen. Amount of oxygen bubble increase in the tube contain hydrogen peroxide and manganese dioxide as a positive catalyst. As we said, again, amount of oxygen bubble increase in the tube contain hydrogen peroxide and manganese dioxide as a positive catalyst. Manganese dioxide is a catalyst which speeds up the reaction. As we said, again, manganese dioxide is a catalyst or act as a catalyst in this reaction which speeds up this reaction. At the last of this lesson, the effect of enzyme on the rate of reaction. The effect of enzyme on the rate of reaction. What's meant by enzyme? As we studied in fourth primary, they are a chemical substance produced by the body, act as a catalyst that increase speed up of biological reaction. As example, a digestive system or digestion process, we can remember that saliva can change starch into sugar as enzyme inside our mouth. Again, saliva can change starch into sugar as we studied in digestive system. So, enzyme, they are a chemical substance produced by the body, act as a catalyst that increases speed up or increases speed of biological reaction. Another example, in our stomach, there are gastric juice which digest the protein or help in digestion of protein. They are example for enzyme. Saliva inside the mouth and gastric juice in our stomach. Important of enzyme in our human body. Help in breathe, move, and digest food, as we said, and increase speed of reaction inside our body. Again, important of enzyme, they help in breathe, move, and digest food, and increase speed of reaction inside body. As example for enzyme, the oxidized enzyme which found in sweet potato. For example, in our chemical reaction in this lesson, an example of an enzyme is the oxidized enzyme found in a sweet potato. Oxidized enzyme in the sweet potato speeds up the breaking of hydrogen peroxide. So, if we put hydrogen peroxide in a test tube and add piece of sweet potato, hydrogen peroxide will be decomposed speed or increase the decomposition of hydrogen peroxide as a catalyst, which we said manganese dioxide. So, oxidase enzyme in the sweet potato speeds up the breaking of hydrogen peroxide. Dear student, I hope to enjoy your time with us. Try to study this lesson very well and answer the question of this lesson. Till we meet you again, goodbye and good luck, everybody.